Ever wonder how one thing can push or pull something else without even touching it? That's not magic, folks. That's electrostatics. Our goal today to predict exactly how these invisible forces will play out. It all comes down to two themes of elections. Meet the two major players in all physics, conductors and insulators. Conductors, like metals, have these free electrons. We call them the travelers. They aren't just tied down to one atom, they roam freely. That means they can move instantly to where they need to go. Insulators, like plastics, wood, or glass, have bound electrons. They're the homebodies. They can't leave their atom, but they can stretch and jiggle a little bit. Let's run the bumper car race. Scenario 1. A charged rod approaches a neutral conductor. Because the conductor's electrons are free, they all rush over to the attractive positive charge. We call this induction. The whole block separates into a charged surface near the rod and a different charged surface far away. Our first prediction rule. When a charged object approaches a conductor, the force is always a strong attraction because the free electrons can fully separate. Scenario 2. The same charged rod approaches a neutral insulator. The homebodies can't leave, but they can polarize. They stretch and shift slightly inside their atoms. They create a little negative surface near the rod, but the object is still net neutral. Second prediction rule. When a charged object approaches an insulator, the force is always a weak attraction due to this internal polarization. Here's the core concept you need to predict anything. A charged object will always attract a neutral object, but the mechanism is different. To check. Negative balloon near a wooden cabinet. The wood is an insulator. So what happens? Polarization, which means attraction. You now know the secret life of electrons, whether they are free roaming, travelers, or homebody shifters. Use this knowledge to predict the forces in the universe. Thanks for joining the race. Now you go explore some static electricity. See you next time.